Everyone, in this presentation we are going to understand the onboard peripherals of Vi-Microsystem kit, which uses ARM7 based LPC2148 microcontroller. So in this screen, if you see, that is number 1. The screen there is so number 1. Number 1 is a LPC2148 microcontroller. You can see NXP LPC2148 microcontroller. So the kit is available here. So this is our LPC2148 microcontroller, which is ARM7 based microcontroller, which is quad inline package with 64 pin. So coming to the second part, it talks about the power supply section. So this is the power supply section, where the power supply section is available here in this kit. So coming to the third part of the thing, RS232 connector, that is COM port connector is there in 3, which is 3. Look at the screen here, it is 3. So here through RS232 cable, through COM port, through RS232 cable, this kit is connected with the PC through CP210 to USB to UART connector. Okay, so PC has USB port, this kit has RS232 port. So through USB to UART protocol converter CP210, we are interconnecting the PC with the LPC2148 kit for programming as well as for communication. Okay, so coming to the third one is our RS232. Fourth one is nothing but stepper motor connector. So in the left bottom corner of the kit, you can see the fourth one, which is the connector. This white color connector is for interfacing the stepper motor in this Vi-Microsystem kit. Then if you go to the fifth part, so program or execution switch and reset switch. Here you can see, so this portion, look at the screen, look at the cursor here, this is the programming switch as well as execution switch. That means when you push the switch downwards, it is for programming. After programming, when you have to push the switch upwards for executing. So this is the reset switch. So programming and reset switch, you can verify in this kit. So here, this is the switch. When I push this downwards, it is meant for programming, and when I push the switch upwards, it is for executing. So this is the reset switch. So this is the programming switch, and this is the reset switch, which is mentioned. Then here in the sixth one is 8-way dual inline package switch. 8-way dual inline package switch is this sixth one, as you see here in the screen. This is 8-pin dual inline package switch. So this is dual inline package switch. So what is dual inline package switch? Now normally it is off. So when you press up means it is on. See, 1 on, 2 on, 3 on, 4 on, 5 on, 6 on, 7 on, 8 on. So this is dip switch. Normally we call this as a dip switch. All the 8 switches are on. Now all the 8 switches are off. Something like that. Okay. So this is the dual inline package switch, which is the sixth one with respect to this Vi-Microsystem user manual. And the ninth and the seventh one is an LED. So here you can see the blinking of an LED in the kit, right? So here is the LED, 7 SMD package LEDs, 8 LEDs. The number 7 is LEDs, which is 8 LED. Look at the board. So those 8 LEDs are blinking here. Here there is a current limiting resistor. Okay, so 8 LEDs, which is number 7 with respect to Vi-Microsystem kit. And the 8th one is 128x64 graphics LCD. So this is the again another feature called the graphics LCD feature. So as you see here, so this is the 128x64 graphics LCD, where we can bring in any graphics from the LPC2148 microcontroller. So then the 9th one is 16x2 LCD. As you see here, this is the 9th one, which is 16x2 LCD, where we can display the alphanumerical characters. And as you see in this, here there is a 9th pin, which is 16x2 LCD in Vi-Microsystem kit. And the 10th one is 7 segment display. So here we can see that 7 segment display. There are 1, 2, 3, 4, 5, 6, 7 segment displays. Here you can see all the 7 segment displays are glowing. So it displays 8, 8, 8, 8, 8, 8. So there are 6 multiplexer 7 segment displays which are connected in the Vi-Microsystem kit, which is 10th point. 11th one is buzzers. Yes, here we have a big buzzer just to notify for our projects. We can use 11 pin. So this is the buzzer here. So this is the big buzzer for producing sound, tone, or whatever you call. And the 12th one is a relay. So where is 12? So this is the 12th one, which is relay. There are two relays available. So these two relays can be used for switching on and switch off the higher voltage appliances or high power appliances. And the relay connectors is 21, right? Relay connectors are 21, where the common, normally closed, normally open, common, normally closed, normally open. So the relay connectors are here in the 21. So where the common input and the normally open, normally closed outputs can be taken out to interface the high voltage appliances to this kit. So coming to the 13th one is RTC. So there is an external RTC available in this board, even though LPC2148 has internal RTC, but the board provides external RTC, which is 13 pin. Whenever there is an RTC, we have to look at the crystal oscillator about 32.768 kHz. Here you can see crystal oscillator of 32.768 kHz crystal, and there should be a battery backup for storing the thing. So here you can see, here also you can see this is real-time clock with 32.768 kHz crystal for producing the real-time in hours, minutes and seconds. So the 14th one is the keypad. As you see here, 4x4 matrix keypad is also available here, and this is the 4x4 matrix keypad with respect to Vi-Microsystem kit. And the 15th one is port for keyboard. This is the connector, right? This is the connector. 15th one is the connector. That means 17th one is connected to the LPC2148 microcontroller. So through a cable, either we can connect to the matrix keyboard, or either we can connect it to the dip switch. So either LPC2148 can be connected to the dip switch or 4x4 matrix keyboard. So that is why this cable. If you look at here, now the port pins are connected to the dip switch. If you want to connect this 4x4 matrix keyboard, so we have to disconnect this cable and then we have to connect to this. Now the 4x4 matrix keyboard is connected to the corresponding port of LPC2148 microcontroller. So this facility makes us to interface 4x4 matrix keyboard with LPC2148 as well as the dip switch with LPC2148 microcontroller as per our convenience. And as told, right, 15 is for port for keyboard, and 15 is port for keyboard, and 16 port for dip switch. So either dip switch or keyboard can be connected to the 17th pin, which is IO port. And 18th is our P3 expander. So this is our the GPIO can be extended, so which is shown here. So this is PC expander. So where the input outputs can be extended out if there is further input output is necessary. So 19th point is I square C terminal. So this is I square C. This is I square C terminal 19. So SDA and SCL can be taken out. So in the kit, if you see, this is SDA and SCL. So two I square C data pin, serial data and serial clock can be taken out to interface with the I square C peripherals if necessary. And the 20th one is PWM terminal. So this is the PWM terminal, which is 20 pin. So through this connector, we can take out the PWM output, which can be used for controlling the speed of the DC motor or changing the position of the servo motor, as well as changing light intensity as per our need through 20 pin. So 21th connector is relay terminals as discussed right now. So the relay, two relays, so 6 terminals is 21. So those 6 terminals are here. So common, normally closed, normally open. Then for first relay, common, normally closed, normally open for second relay. So for connecting the output devices, high power output devices, we can use this connector and we can use this relay. And coming to this 22 AD590 connector. So 22nd is AD590 connector for connecting some more peripherals, as we see here 22. So here these two connectors are AD590 connector for interconnecting much more peripherals. And trim part for ADC. So ADC needs analog input. So to give the analog input to the analog to digital converter, there is a potentiometer. So there is a potentiometer which is 23. So here you can see this is the potentiometer. So through this potentiometer we can able to give the analog input to the on-chip ADC of LPC2148. No need for any external analog source for testing the ADC of LPC2148. So 23 can serve as an analog input source for the on-chip ADC of LPC2148 microcontroller. And 24 is an interrupt switch. So hardware interrupt, maybe falling edge interrupt, rising edge interrupt, level 0 interrupt, level 1 interrupt can be done by using this switch, which is interrupt switch. As you see here, this is interrupt switch. And 25 is a prototype area where we can use our own circuit here for our particular application. By using this particular area, we can use this. And in 26 is our external 5V supply for stepper motor. So when you connect a stepper motor, we need to provide an external 5V use by using this 26th connector. So as you see here, so for stepper motor, the external 5V would be provided through this. So these are all the major features which we have to explore with Vi-Microsystem kit. In the following classes, we will explore one by one, starting from LED blinking as you see right now. So how this LED blinks, that will be discussed in the next presentation. Thank you very much.